Welcome back to Nexus Tech. Today we're diving into the incredible story of the internet, a journey that started with a Cold War defense project and ended up as the global network that, let's be honest, runs our entire modern world. So it really all boils down to this one central question, right? How in the world did a military experiment, a thing designed to survive nuclear war, become the backbone of our modern lives? How did it go from apocalypse-proof to delivering cat videos? Let's get into it. All right, to really understand this, we've got to go back. And our story doesn't start in some sunny Silicon Valley garage. Nope. It starts in the thick of the Cold War. So picture this. The U.S. military has a massive problem. They're terrified that a single nuclear strike could take out their central command, and poof, all communication is gone. It's a single point of failure, and in a nuclear standoff, that's a nightmare. They needed a network that could actually survive an attack. And the solution they came up with was just brilliant. It's called packet switching. And honestly, the concept is way simpler than it sounds. Think about it like this. You need to mail a book. Instead of putting the whole book in one big box that could get lost, you tear out every single page and mail each one like a postcard. Some postcards might take a weird route, some might even get lost, but most of them are going to get there. And at the other end, you just reassemble them. That's it. That's packet switching. It's a system designed for chaos, which makes it unbelievably tough. So that theory, packet switching, it needed a real-world test. And that test was called ARPANET. And you got to remember, this wasn't some huge global thing yet. We're talking December 1969. It was literally just 4 computers at 4 universities: UCLA, Stanford, UCSB, and Utah. That's it. A tiny little network, but it was the seed, the proof that this crazy idea could actually work. Okay, so ARPANET is a hit. It works. But success creates new problems, right? As the network grew and other totally separate networks started popping up, they ran into a new wall. The issue was that all these different networks, they couldn't talk to each other. It was like having a room full of people all shouting in different languages, a complete digital Tower of Babel. You had ARPANET over here, some other network over there, and no way to bridge the gap. This was a huge roadblock to the idea of a truly global network. And this is where 2 absolute legends, Vinton Cerf and Robert Kahn, come in. They developed something called TCP/IP. You can just think of it as the universal translator for computer networks. It basically said, look, I don't care how your individual network is built. As long as you speak TCP/IP, you can talk to everyone else who speaks TCP/IP. This was the key. It allowed them to create a network of networks, which, well, that's literally the definition of the internet. Which brings us to a really important date, January 1st, 1983. They called it Flag Day. On this day, the entire ARPANET had to switch over to the new TCP/IP protocol, all at once. It was a huge gamble. If it failed, the whole thing could have collapsed. But it didn't. It worked perfectly. And for a lot of people in the know, this is the real birthday of the internet. Okay, so now all the networks can talk. Awesome. But, solving one problem just uncovers the next one. With TCP/IP, every single computer connected to the network gets a unique numerical address, an IP address, like 142.250 and so on. That's great for computers, but for us humans, no way. Could you imagine having to memorize a string of numbers for every website you visit? It was just not going to work for regular people. The solution is something we still use every single day, the Domain Name System, or DNS. Invented by Paul Machapeteris, it's basically the internet's giant address book. When you type a name like google.com into your browser, DNS is the system that quietly works in the background, looks up that name, and finds the correct number for your computer to connect to. It's this simple, elegant solution that makes the whole thing usable for normal people. All right, let's recap. We've got a global network, the computers can talk to each other, we've got an address book to find them, but there's still a massive piece of the puzzle missing. How do you actually navigate all the information that's on those computers? How do you get to the good stuff? Think of it this way. You have the world's biggest library, but there's no card catalog, no signs on the shelves, and every book is locked in a different room. That's what the internet was like. All this information was there, but to get it, you had to be an expert. You needed to know these complex commands. It was totally inaccessible to most people. And this brings us to Tim Berners-Lee, a scientist working at CERN. He saw this problem and came up with an amazing solution. He created 3 key things that all work together. First, HTML, the language to actually build the pages. Second, URLs, so every single page has its own unique address. And third, HTTP, the protocol that lets your computer ask for and get those pages. This whole system, which sits on top of the existing internet, he called the World Wide Web. And then came August 23rd, 1991. That's the day the World Wide Web was officially opened up to the public. And this was the moment everything changed. This is when the internet went from being a tool for scientists and soldiers to a space for literally everyone. So the web is out there. It's public. Now, the race was on to build the best tool to explore it. And this kicked off the internet's very first big corporate battle. This battle was all about the browser. First came Netscape Navigator, which was an absolute game changer. It was easy to use, it was graphical, and it blew up. It took over something like 80% of the market, just like that. But of course, Microsoft was watching. They knew the browser was the gateway to the internet, and they were not going to be left out. So they launched Internet Explorer. And the speed at which the tables turned is just wild. So how did Microsoft pull it off? One word: bundling. They just included Internet Explorer for free with every single copy of Windows 95. And since almost everyone was using Windows, they had a huge built-in advantage. By 1998, the game was over. Netscape was crushed, and IE dominated the market. The first browser war had a clear winner. With the browser wars settled, the web was here to stay, and the pace of innovation just went into hyperdrive. In '98, Google shows up and finally makes it easy to find stuff. Then, in 2004, Facebook launches, and suddenly, the social media era begins. And then, of course, 2007, the iPhone. It literally put the entire internet in our pockets, and nothing has been the same since. You know, this constant evolution, from these early breakthroughs to the challenges we're facing right now, that's exactly what we love digging into here. So if you want to stay on top of the technology that is literally shaping our world, do us a favor and hit that subscribe button for the Nexus Tech channel. It really helps us out. So that whole journey brings us right up to today. And the internet, well, it's not some side project anymore. It's the foundation of everything. And that means it's facing a whole new set of really complicated problems. Yeah, the big debates today aren't about technical protocols anymore. They're about power and control. We're asking huge questions, like with net neutrality, who gets to decide which data moves fast and which moves slow? With cybersecurity, how on earth do we protect this global thing we all rely on? And then you've got Web3, making us ask, could we build a new internet that's more decentralized, one that's owned by the users? These are the massive, unanswered questions we're grappling with right now. You know, when you think about it, the first internet was this incredible achievement in connecting machines. Today's internet, with AI and everything else, it's all about connecting intelligence. So that leaves us with a big question, right? What's next? What will the internet of the future connect?